Hello. Today we're going to spend some time looking at the LDL range of products available from motion control products, specifically aimed at replacing pneumatic actuators. My name's Tony Robinson, and today I'm talking to Romain Girard about the LDL range of products, specifically looking at the product itself and how it can be used to replace a pneumatic system. Hello, Romain.
Hi, Tony.
Can you explain to me what we've got on the table here in front of us?
Yeah, sure. So we have different products of our latest range, the LDL actuator. We have the open view in the middle, and at the side we've got different categories of products.
Yeah. So these are all basically of one family?
Yes.
Okay. The cutaway shows us the basic construction, and there is a separate video of that if you want to go and watch it. Okay. And here we've got a range of products, fundamentally all linear, but I can see you've got a rotary motor on the end which can be used in conjunction with these. Is that correct?
Yes, that's correct. So it's a product that is in development for that particular range.
Yeah.
And it would be called, for example, the LDR.
Right.
And that would consist in taking the HT35 motor, for example, and putting it inside an LDL 40.
Right.
So therefore you would have the linear motion on the rod, but you also have the rotation from the rotary motor.
Right, I understand.
We also have a bigger version with a bigger motor if more torque is required. Okay. So those units are currently in development, but we have other ranges already available with that technology.
So in the LDL range here in front of us, what is the smallest unit and what is the largest? What forces can you generate?
So the smallest unit would be an LDL 15, which means it would be 15 millimeter thickness.
Yeah.
And the stroke on that unit is 10 millimeter. We're also developing more strokes as the requirement comes on.
Yeah.
On that unit, we would be talking around 15 Newton force using 24 volts DC. Then if you go up a size, you go into the LDL 25 range. So that's 25 millimeter thick. Different strokes from 10 millimeter all the way up to 100 millimeter. Again, that is going to come up even more to even longer strokes. Yeah. And we are talking at about 30 Newton force for the actuator. We then go available as well now is the LDL 40 from 25 millimeter stroke up to 100 millimeter stroke. Right. And we are now in the region of 100 Newton for that unit. Okay. And we're also developing smaller unit and even bigger units as we speak. So we are really expanding the range of LDL.
And they all use the same encoder, incremental encoders, and they're standard as 5 micron.
Exactly, yes. Standard 5 micron, we can go down to 1 micron and 0.5 micron really easily in that range. So depending on the application, we can go down on the precision of the encoder, but 5 micron is usually suitable for most applications.
And you said this is primarily aimed at pneumatic replacement.
Yes.
So why would you want to put this in replacement of a pneumatic system? What are the advantages this gives you over a pneumatic solution?
Many advantages actually. The first one would be the lifetime of the actuator. You are talking more than 100 million cycles before any issues would happen on this technology. Okay. You don't need any maintenance, so you just run them, and well above 100 million cycles, that's only when you start to notice something. Yeah, and you might even not notice it. It really depends on the application, but well over 100 million cycles. The second point would be the noise. You can see we've had the actuator running from the start of the video, and we can still have a conversation. Yeah, the noise
levels are really low. I can't hear anything, to be honest with you.
Yes. So that's the second advantage. The third advantage would be the programmability of the unit. So you can, as you can see again on that running unit, change the stroke. Yeah. You can do any motion you want. You can control the speed, the force, the acceleration, the position, and you can change that anytime. It's just in the software. So doing a changeover on a production line would only take seconds, the time to load the new program, and off you go.
Okay.
So again, a big saving.
So very flexible in a production line application. So if you're running one product down a canning line, for instance, and then you suddenly shift to a different product, you can, by the push of a button, you can instantly change what the application is doing.
Exactly. That could even be controlled from the PLC.
Yeah.
You load that, the operator goes on the PLC, change the line to that product number 2, and everything is automatically set for the actuator.
Okay. It's totally self-contained. You say so. This is the complete unit, either with or without the controller here.
Yes.
So if we were looking at a pneumatic solution to do exactly the same thing, the pneumatic solution would be what, 2 points of motion, bang bang.
Exactly that. Yes. That's what we call them bang bang actuators.
Yeah.
Really loud, 2 position, and no control over the speed, the position, or the accuracy.
Yeah.
Any change requires to adjust the pressure, to adjust the position, the sensors. It's a lot of work just for a small change on these kind of actuators.
And obviously you don't have to worry about things like filters, lubricators, any tubing or anything like that. There's none of that required.
No, exactly. So any environment where contamination is a high risk, you remove that risk straight away. You haven't got that pressure, air pressure that could contaminate a product.
Yeah, I understand. So if a customer came to you and said, I want to replace this a pneumatic, as a pneumatic solution, I want to replace this and put this in its place, how would you go about doing that? What's the requirement? Does he tell you what forces he needs and you then work out what actuator is required?
Pretty much, yeah. An issue we find is in a lot of pneumatic applications, the actuators have been oversized, massively oversized, and customer would say, we need 200 Newton. Actually, no, it's what the pneumatic cylinder is capable of doing, but we don't need 200 Newton. We might need 50 Newton. So that is usually the first step, is making sure the force required is actually the force needed.
Yeah, okay.
And then from that, we can then spec the actuator that would do the job.
And in comparison to a pneumatic solution, are these more expensive? Are they the same price? Where do they lay? Because obviously this is a much more complicated technology than a pneumatic actuator. But I assume because it's a self-contained unit, you don't have to worry about all the peripherals that you would have in the pneumatics. There is a like-for-like comparison, or is it cheaper?
So in terms of like-for-like comparison in pricing, if you just compare the basic pneumatic cylinder with an LDL, the LDL is going to be more expensive.
Yeah.
But if you then include your filter regulator, you need to have the correct air coming in, avoid contamination. Yeah. That's an extra cost. You then have your valve control, you have your pipes, you have your setting up time, you have your commissioning time. Yeah. And like we talked before about mean time before failure. Yeah. A pneumatic actuator, you would hope for 10, maybe 20 million cycles, but that would be about it. With these units, you are well over 100 million cycles. So all those parameters put together, that's where the saving come from. Okay. And it could be about 7 or 8 times more cost effective than pneumatic.
And as you mentioned earlier, this is a force control, velocity control and positioning control in one unit, which obviously pneumatics can't offer. So you get advantages in the fact that you can do a very soft positioning, which you can't do with a pneumatic solution.
Yes, that's right. So we can use that Soft-Land function and come out and detect the product before we actually do anything with the product. Yeah. So that avoids damaging the product, marking it, or creating any issues, for example, in a reject application on milk bottle, for example. Yeah. Pneumatic might knock the bottle and create the liquid to spill. And any spillages in this kind of industry is really bad. They have to stop the line, clean, make sure everything is nice and clean before they can restart. We can soft land on that bottle and then only eject it. So we avoid all these vibrations and spillages. So that could be another huge cost saving for the customer.
Okay. Downtime is always a problem in production line.
It is, it is. And we afford that solution at no extra cost. It's inside, it's capable of doing it.
Okay. Okay, and this is fully programmable with an interface, a GUI interface that you can teach the programming very rapidly.
Yes, exactly. So we have our software that is available, and you just load the program you need for the application, and off you go. And you can even have different programs depending on the product, depending on the speed you're running the line at, the weight of the product, the size of the product. All those parameters can be changed on the fly.
Okay, well, I found that very useful, Romain. Thank you for your time. Okay, I hope you found it useful. If you've got any questions, then please feel free to contact us. Thank you for your time.